April 1945, a New York Central Railroad test facility outside Cleveland. 3 engineers stand beside locomotive number 5500, a brand new high-pressure steam prototype designed to pull passenger trains at unprecedented speeds. They have just completed the morning inspection when the boiler explodes. The blast is instantaneous. All 3 men are killed. Within 48 hours, newspapers across America carry the story. Railroad unions threaten nationwide walkouts. The locomotive class earns a name that will haunt it for years: the man killer. Crews refuse to board. The entire Niagara program, representing millions in investment and years of development, teeters on the brink of cancellation. But here is what almost nobody knows. That same locomotive class, condemned before it ever entered service, would go on to compile the most extraordinary safety record in American steam railroad history. 0 boiler failures, 0 crew fatalities, 5.2 million miles of operation without a single catastrophic incident. How does the deadliest locomotive prototype in America become the safest steam engine ever built? The New York Central Railroad did not build the Niagara to kill men. They built it to save steam. By 1944, diesel-electric locomotives were making promises that steam could not match: lower operating costs, less maintenance, higher reliability. The Central's response was the Niagara, a 484 express passenger locomotive designed to run at 80 miles per hour while pulling 17 heavyweight cars. At 275 pounds per square inch, its boiler operated at pressures that would make most railroad engineers nervous. High pressure meant high power. It also meant high risk. The April 1945 explosion during factory testing was not a minor incident. The boiler shell ruptured catastrophically, releasing superheated steam at temperatures exceeding 400 degrees Fahrenheit. The force of the blast was heard 3 miles away. Federal investigators arrived within hours. Their preliminary report was damning. The failure originated in the boiler's firebox crown sheet, where a design flaw had created a critical weakness. 3 engineers were dead. Their names were Charles Morrison, Frank Delaney, and Robert Chen. They were men with families, decades of experience, and no reason to expect that a routine test would be their last. The Brotherhood of Locomotive Engineers issued an ultimatum: fix it or we will not operate it. The New York Central faced a binary choice. They could scrap the entire Niagara program, writing off $4.2 million in development costs and admitting defeat to diesel. Or they could do something American railroads had rarely attempted: redesign a locomotive class not for performance, but for absolute safety. They chose the gamble. What happened next was unprecedented in steam locomotive history. Paul Kiefer, the New York Central's chief mechanical engineer, convened a design review board with a single mandate: prevent another explosion, regardless of cost or weight penalties. This wasn't optimization, it was paranoia converted into engineering specifications. Every component was scrutinized. The firebox crown sheet, the point of failure, was completely redesigned with thicker steel plating and improved water circulation patterns. But Kiefer didn't stop there. The Niagara's boiler received redundant safety systems that bordered on obsessive. 3 separate sets of fusible plugs were installed. These were lead alloy devices designed to melt and release steam before pressure could reach dangerous levels. 5 spring-loaded safety valves, each independently tested to open at precise thresholds, crowned the boiler. Any one of them could prevent catastrophe. The Niagara had 5 safety valves. The boiler shell itself was reinforced, increasing the locomotive's weight by 8,400 pounds, nearly 4 tons of additional steel devoted solely to structural integrity. Operating pressure was reduced from 275 to 265 pounds per square inch, sacrificing power for margin of error. But the most radical change was invisible: the inspection protocol. Kiefer mandated that every Niagara undergo monthly ultrasonic boiler inspections, a time-consuming process that required specialized equipment and trained technicians. The firebox crown sheath received weekly visual inspections. Water treatment became a science project, with chemists monitoring boiler water quality to prevent scale buildup and corrosion. Critics within the railroad called it excessive. They argued the Niagara was becoming too heavy, too expensive, too complex to operate economically. One New York Central executive memo, dated July 1945, questioned whether a locomotive wrapped in bubble wrap could compete with diesel. Kiefer's response was coldly pragmatic. "I'd rather defend an expensive locomotive than explain another coffin." The redesigned Niagaras entered production in late 1945. 27 locomotives were ultimately built. When the first unit rolled out of the Alico plant in Schenectady, New York, it weighed 471,000 pounds, heavier than any passenger locomotive the Central had ever operated, and it still carried the nickname no one wanted to say aloud. The real test was not in the factory, it was on the mainline. In March 1946, Niagara No. 6000 departed Chicago's LaSalle Street Station, pulling the prestigious 20th Century Limited 18 cars, 1,100 tons, destination New York. The engineer was a 22-year veteran named Thomas Rigby, who had publicly stated he would rather shovel coal into hell than operate that death trap. He was assigned to the run anyway. Rigby later described the experience in testimony before a Railway Labor Board hearing. He said he spent the first 100 miles waiting for the firebox to blow. By Toledo, he had stopped checking the pressure gauge every 30 seconds. By Cleveland, he started trusting it. That single run began a process of reputation rehabilitation that would take years. The Niagaras operated in the most demanding service profile imaginable, high-speed passenger trains on tight schedules, often running 800 to 900 miles between servicing stops. They hauled the Central's premier trains, the 20th Century Limited, the Commodore Vanderbilt, the Empire State Express, where delays meant headlines and mechanical failures meant disaster. Month after month, they performed flawlessly. By 1948, the Niagara fleet had accumulated over 800,000 miles. Other railroads were suffering boiler incidents. The Pennsylvania Railroad experienced 3 firebox failures that year alone, and the Santa Fe had 2. The New York Central's Niagaras? 0. Crews began requesting them. The locomotives that men had refused to board became the most sought-after assignments on the railroad. Engineers appreciated the smooth ride, the responsive controls, the overwhelming sense that everything had been built twice as strong as necessary. Which, of course, it had been. By 1952, something extraordinary was becoming undeniable. The Niagara class had operated for 7 years without a single boiler-related casualty. Not one ruptured firebox, not one safety valve failure, not one pressure-related incident requiring federal investigation. The numbers were staggering: 3.4 million miles of operation across the entire fleet, 0 catastrophic failures. Federal Railroad Administration records from the period show that between 1945 and 1955, American railroads experienced an average of 7.3 boiler failures per million locomotive miles. Most were minor, relief valves blowing, tubes leaking. Some were not. The industry standard was that high-pressure steam locomotives would eventually fail. And the question was, when, not if. The Niagaras broke the curve. Independent railway engineering journals began documenting the anomaly. A 1953 article in Railway Mechanical Engineer noted that the Niagara's safety record defies statistical expectation for locomotives operating at this pressure and intensity. A Society of Automotive Engineers study concluded that the Niagara's redundant safety systems had created the most fault-tolerant steam locomotive design in American history. The Brotherhood of Locomotive Engineers, the same union that had threatened walkouts in 1945, issued a formal commendation in 1954, praising the Niagara as proof that steam power and crew safety are not mutually exclusive. Paul Kiefer, now retired, was asked in a 1955 interview whether the extensive safety features had been worth the additional cost. His response was simple. He said, "Ask the widows of Morrison, Delaney, and Chen whether 8,000 pounds of extra steel is expensive." By the time the last Niagara was retired in 1958, the class had accumulated 5.2 million miles of operation, 13 years of service, 0 boiler explosions, 0 crew fatalities from mechanical failure. The locomotive, once called the man killer, had protected more lives than any comparable steam engine in American railroad history. But here's the brutal truth. It didn't matter. Even as the Niagaras were proving steam could be extraordinarily safe, diesel-electric locomotives were proving they could be extraordinarily cheap. The economics were irrefutable. A diesel locomotive required 1/3 the maintenance hours, eliminated the need for water stops, and could operate for days without servicing. The New York Central began dieselization in earnest in 1954. By 1956, the Niagaras, still mechanically sound, still flawlessly safe, were being systematically sidelined. The last revenue run occurred in April 1958. None of the 27 Niagaras were preserved. They were all scrapped, cut apart for their steel. Their boilers were dismantled, and their innovative safety systems were destroyed. The machine that had solved steam's greatest liability arrived exactly when the industry no longer cared about solving it. The Niagara proved that high-pressure steam could be as safe as any diesel. It proved that rigorous engineering could overcome catastrophic failure. It proved that tragedy could be transformed into triumph. It proved all of this too late to save steam itself. The story of the Niagara is not really about locomotives. It is about what humans do after failure. When 3 men died in April 1945, the New York Central could have walked away. They could have blamed the technology, declared steam obsolete, and moved on. Instead, they made failure unacceptable. They over-engineered until disasters became statistically impossible. They turned a machine that killed men into a machine that protected them. Today, every industry that builds systems capable of killing people, from commercial aviation to nuclear power, operates on the same principle the Niagara proved. True safety is not the absence of failure. It is the humility to learn from it. The locomotive nicknamed Man Killer ran 5.2 million miles and never killed anyone again. Maybe that is the only redemption that matters.